Boom! What up, math nerds and mathletes? Coach Murphy here. Let's jump back in that volume grind, huh? Yeah. Let's start talking about spheres. Every single one of you guys know what a sphere is: a basketball, a baseball, uh, anything that's a three-dimensional circle, right? A globe. Okay. And so we're going to look at a scoop of ice cream, right? Put a scoop of ice cream on top of an ice cream cone. Now we have two three-dimensional shapes put together. We have a sphere and a cone, right? Probably the greatest three-dimensional shape. Had some ice cream last night. It was delicious. It was cookies and cream. I always go cookies and cream. I mean, rarely ever do I deviate from that. I just feel you can't go wrong with it. It's like an Oreo ice cream. I just it's pretty phenomenal, if I do have to say so. Anyways, I digress. Let's talk about spheres. Let's talk about how to find the volume. All right, strap in. Let's jump on that math grind. Get that vaunted math bread.
Spheres. Alright, let's just look at our good old friend the sphere. Okay, so volume of a sphere. Pretty simple actually. We got the volume equals 4/3 pi r cubed. Okay, we know that a sphere is a solid in which each point is equidistant from the center. Think about basketball, a baseball, right? Soccer ball, volleyball, lacrosse ball. I don't know what they call them. I have no idea. Um, there is just one thing we need to know. Let's call it a great circle. And the great circle, it slices a sphere into two hemispheres. Yeah, right. Pretty awesome. Okay. So let's go ahead and just quickly look at some problems here. So we zoom in here. Alright, the big thing we need to know when we're dealing with trying to find the area of a sphere, we need to know the radius. Right? As soon as we can identify the radius, we are golden. Alright, so the radius here is 7. So we know volume equals 4/3 pi r cubed, or it could be 4 times pi r cubed divided by 3, whichever one you want. Okay, so we got 4 times pi, got the radius is 7, we're going to cube that bad boy, and divide it by 3. Plug that into our calculadora, we get 1,436.76 cubic inches. Right, nothing too crazy. We look down here, bam, that is not the radius, that is the diameter. We need to take half of that, right, giving us 16.5 as the radius. Then we can go ahead and plug that in. Alright? Sounds good? Okay. Let's get something else. If we have a hemisphere, so volume of a hemisphere. Hemisphere is half of a sphere, right? The volume of the hemisphere is 2/3 pi r cubed, or 2 times pi r cubed divided by 3. Okay? Nothing too crazy. Jump back over here. So we go down right here. Once again, important to identify the radius. We got 5. We know that the volume of a hemisphere is 2 times pi r cubed divided by 3. Alright, so we can go ahead, plug all of that in. Got 2 pi 5 cubed divided by 3. Plug it into our calculator, we get 261.8 cubic kilometers. Alright, nothing too crazy. Fairly simple. Let's go ahead and look at some applications here. This It says find the volume of a sphere with a great circle area of 201.06 square inches. Right? So, we need to go ahead and find the radius of this sphere. Well, we don't know it, but we know that the great circle, which is a circle that cuts it in half, has an area of 201.06. So if we just look here, the great circle is right here. Okay? Right here. It's this circle that comes through and just slices this sphere in half. Okay? So, we go back. Let me get back to my spheres here. And we know it's a circle. So our area of a circle, area equals pi r squared. Alright, so if we're trying to find the radius because we need that to find the volume, we just plug in 201.06 equals pi r squared. Right? We divide pi out. Right? That gives us something like 64 equals r squared. We do square root, r equals 8. Now we're ready to rock and roll on the volume. The volume of a sphere, 4 times pi r cubed divided by 3. Alright, we go ahead and we plug in our radius, plug all that into our calculator, and we're left with 2,144.66 cubic inches. Okay. Alright. Let's look at this composite figure. Once again, looks like someone dropped their ice cream cone. So very sad. We're not worrying about surface area. Don't have to worry about that. Let's look at this silo right here. So, we got a hemisphere right there, and we got a cylinder right there. Okay? We know that the volume of a hemisphere is 2 pi r cubed divided by 3. And we know that the volume of a cylinder is pi r squared times height. Okay, in this figure, the diameter is 22, meaning the radius is 11. Okay, if this from here to here is 11, from here to here is 11 as well. So the height of this is actually 45 minus 11. Okay, which gives us 34. So, we go ahead and we can plug in 2 times pi 11 cubed divided by 3. And that gives us that volume. Get my calculator out here, my calculator turned off, so we got 2 times 3.14 times 1898.89. And then over here we have pi times 11 squared times the height, which is 34. 3.11 squared times 3.14 times 4. So we are left with 12,097. Right? And we are going to add the two together. So we're trying to find the combined that they can hold. Alright? Trying to find the combined that they can hold. So we add these two together.